In a regular HVAC system, normally we have some outdoor air coming from outside, from our outside air temperature sensor detects that. So we have some outdoor air coming from outside, and then we do a process of cooling. We do a process of heating, and then we gather some of the air from the rooms. So this is return. This is return air, and then we exhaust this air, but we keep some of it, and that's our mixed air. So I'm going to show you what that means in terms of the thermodynamic cycle, in terms of the enthalpy, pressure, temperature, all of the variables that we can determine from a first law energy balance across typical refrigeration and heating system applied to an entire industrial or commercial building. So let me just label on here these areas that we're looking at here then in green. So we have some outdoor air that's typically called A. We have some mixed air because we got some air returned from the room. Well, this really, the room is here. So it's returned from the room. And then here we go, mix it with the outdoor air. And that is our mixed air. We're going to call E is our mixed air. So there's outdoor air, there's mixed air. And then there is processed air, supply air, and zone air. So we are going to supply this cooled and heated air into the room, and that's the supply air. And then we have zone air is what is has to actually heat and cool the zone. So we need a zone being drawn on here. So this is our building, our entire building. And then we have to have a zone inside that building that we're supplying to and we're returning from. And we're going to have supply air into that zone, and we're going to have some processed air coming out before it can get supplied into that zone. Okay, so let's look at what this actually looks like. Outdoor air, mixed air, processed air, supply air, and zone air in terms of our thermodynamics. So what I've drawn here is the typical HVAC system again. I just don't have the, the ventilation that we typically draw on an HVAC system. But this looks confusing, but let's actually just work it out. So in any thermodynamics problem, you know from me that all thermodynamics problems have to be dealt with within a boundary. So the boundary that we have drawn here for our thermodynamic system, it is a closed boundary that we're doing thermodynamics on. And it can be defined here with these dotted lines. And I'm just going to turn this into sort of a disappearing ink. So this is the thermodynamic boundary that we are going to represent our thermodynamics of refrigeration and heating over. That's our closed boundary. Now, we also have to talk about where are the people. So here are the happy people inside the building zone here, okay? These are the people that we want to spend money on keeping happy. So we can call a building zone maybe a classroom or a room in a facility, okay? So we want to heat or cool and make happy these occupants in this room. But the rest of this facility is outside of the building zone. So all of this is inside our vents, our ductwork, our mechanical room. It has our chillers and our boilers and our all of the rest of our HVAC system, our building controls, everything. Okay, so let me just summarize this. Thermodynamic boundary, building zone where we want to make people comfortable in heating and cooling and stoichiometrics like your humidity. And then you have the rest of the system that's kind of the ugly part that people are not walking in. Okay, that's what we have so far here. Now, in order to make a nice building zone for these wonderful people, we have to first make sure that it's a fresh zone. So that's where we get ventilated air in. So we take in this air, and this is called our outside air. So our outside air temperature is over here. I'm just going to put that on permanently, that this outside has outside air temperature, or OAT, it's commonly referred to, outside air temperature. Now, this outside air is fresh. And the reason we want it is it's fresh air. And so we're not going to have the stale air inside this building zone. It's going to help us with things like, carbon monoxide buildup. You don't want carbon monoxide buildup in stale air. You don't want to kill the canary in the coal mine. So you bring in this nice fresh air, and that is a requirement. And that nice fresh air that you bring in, the problem with it is it's too hot or it's too cold, usually, especially where I'm coming from making this video right now. I am in Southern Ontario. So we are here, and this is my, I have to cool this air and I have to heat this air, right? So this air, this air that came from ventilation, I'm not talking about mixed right now, I'm talking about ventilation, has to be cooled and heated. And what we usually do that with is some coils. Now, these coils are usually in something called an air handler unit, and I'm going to put that in there permanently for you as well. Air handling unit. And an air handling unit is usually made with these coils on this side and coils on this side, one side for hot and one side for cold. And it is just a heat exchanger. An air handling unit is just a heat exchanger. And those sides that are hot and cold go off to a chiller and a boiler. So there's a coil for hot and a coil for cold. And we label this across here as cooling. And then we can look at this separately as heating. And then if you've gone through your cooling and your heating, then you call that supply air, right? So that's what you are going to supply to these happy people in here. So again, I'll go over this again. We take air from outside. We cool it because it's not good enough for where we are right now. And we heat it because it's not good enough for where we are right now. And then we supply it. It's called processed after you cooled it, and it's called supply after it's been cooled and heat. It's just what it is. And then it is inside here, and then everybody is happy. Now, they're happy, but they're also kind of like dirty. These are happy, dirty people. By dirty, I mean they're breathing out carbon dioxide. So they're putting carbon monoxide and carbon dioxide into the air. So we need to steal their air back again, and we need to get rid of that dirty air. So there we go. We're exhausting that air. We're going to steal that air from them, and we exhaust it because these people were a little bit dirty in their breath. But do we want to exhaust all of it? You don't want to exhaust all of it because, as we've discussed, you want to return some of it because it costs money to have been doing that cooling and that heating. So that is, we don't want to waste it. So this is waste in order to, maintain those pressures and be able to get in ventilation air. This is recovered because now as it's going into the cooling coil, maybe you don't have to do as much cooling, or as it's going into the heating, you don't have to do as much heating. All right, so that's my description of this system. But what I also want to tell you is the thermodynamics of the system. So you need to be able to relate each section here, each section A, E, C, S, and Z, enthalpy curve. And that is something that we are going to figure out together.